Welcome back to The Explainer. Today we are diving into something truly epic, the journey of a river. We're going to follow the water and see exactly how it literally sculpts the world around us. Take a look at this. It might look like the end of the line. And in a way it is. This is the Yukon Delta, this massive landscape that was built literally from scratch by the river itself. But our story doesn't begin here. No. It starts way, way upstream, with just a single drop of water and maybe a tiny grain of sand. So the big question is, how? How on earth does a river build an entire landscape like that? Well, to figure that out, we need to zoom way in. We're going to follow the journey of one single particle of rock right from the moment it gets ripped free all the way to its final resting place. Ready? Let's get into it. Okay, so a river's first job is basically to gather its tools. And what are its tools? Well, it's the rocks and the soil that it's going to use to carve up the land. Geologists, of course, have a name for this, erosion, and rivers have like 3 main tricks up their sleeve to get it done. All right, so first up, you've got turbulence. Just imagine the sheer force of all that swirling, chaotic water. It's constantly prying bits of rock and dirt loose. Then you've got collision. See the rocks the river is already carrying? They act like a sandblaster, just smashing into the riverbed and chipping off even more pieces. And last but not least, there's dissolution. The water itself is like a weak acid, chemically dissolving certain minerals right out of the rock. Pretty cool, right? So once a particle is broken free, it's off on its big adventure downstream. You could think of it as a great migration. But here's the thing, not everything travels the same way. Okay, first up, you've got what's called the suspended load. I like to call them the floaters. These are these super tiny particles, silt and clay, that are so light they just get carried along in the water itself. It's kind of like dust motes floating in a sunbeam. This is exactly what makes a river look muddy. Then you've got the bouncers. These are the bigger, sand-sized grains. They're too heavy to float, so they do this incredible dance called saltation. The current picks them up, they do a little hop, and then they fall back down. But when they land, they knock another grain of sand up into the flow. It's this amazing non-stop chain reaction of bouncing that moves just tons and tons of sand downriver. And finally, we've got the real heavyweights, the bed load. We're talking about the big stuff here. Gravel, cobbles, even boulders. Think of these as the river's bulldozers. They don't bounce, they don't float, they get rolled, pushed, and slid along the very bottom. And this really only happens when the river is truly raging, like during a major flood. Okay, so the river's picked up all this material, floaters, bouncers, rollers, but how does it decide what to keep carrying and what to, drop? I mean, it can't carry everything forever, right? It all boils down to one super simple but absolutely critical factor: speed. There's a great term for this. It's called stream competence. And really, it's just a fancy way of saying how powerful the river is. The faster the water's moving, the more energy it has, and the bigger the stuff it can lug around. It's pretty intuitive, right? A fast, raging mountain stream? Yeah, it can move boulders. But a slow, lazy, meandering river? It might only have enough oomph to carry some fine silt. And this table here lays it out perfectly. Look. When the velocity is high, the river is a beast. It carries everything. But the moment it starts to slow down, it starts losing energy. And what does it drop first? The heaviest stuff. Out go the gravel and sand. The really fine silt and clay, though, they can stay floating for a lot longer, even when the water is barely moving. So you have this constant cycle, right? Pick stuff up, carry it for a while, and then drop it. But this is not random. Not at all. This is actually a creative process. It's how the river becomes an artist, sculpting the incredible landscapes and features we see all over the world. And I think the most iconic example of this has to be meanders. You know what I'm talking about, those beautiful, lazy, S-shaped curves in a river. They are the perfect showcase of the river's artistry, and it's all about that delicate dance between speed, erosion, and, you guessed it, deposition. Okay, check this out. It's so cool how this works. Think about a car going around a racetrack. On the outside of a curve, you have to go faster to keep up, right? Same with the water. It speeds up on the outside bend. More speed means more energy, which means more erosion. That's where it carves out a deep channel called a cut bank. But on the inside of the bend, the water is moving slower. It's the lazy lane. Slower water loses energy, so it drops its sediment, building up a sandy little beach called a point bar. So what you have is this constant erosion on one side and building on the other. This means the meander is actually moving, migrating across the valley over time. And sometimes the S-curve gets more and more extreme, until the two ends of the loop get really close. Then, bam! During a big flood, the river just says forget this and takes a shortcut, punching straight through. The old loop gets cut off, abandoned by the river, and what's left behind is this beautiful crescent-shaped lake. We call that an oxbow lake. It's like a little ghost of where the river used to be. And that brings us all the way back to where we started, the grand finale, the masterpiece. After its incredible journey, when the river finally hits the calm water of a lake or an ocean, it just stops. The velocity drops to basically zero, and when it stops, it drops everything it's still carrying. All that silt, all that sand, everything it's carried for hundreds, maybe thousands of miles, it all gets laid down right there. And piece by piece, it builds brand new land. That's exactly what you're seeing in this amazing shot of the Yukon Delta. And, it's so important to remember that no river works alone. They're all part of these huge networks. Just look at this map of the drainage basins in North America. Every single little creek, every stream, they all connect into this massive continental plumbing system. They're all working together, carrying water and sediment towards the ocean, and all of them, together, are reshaping the face of the continent. So, next time you see a river, think about this. Whether it's a tiny stream carving through a hillside or a massive river building a delta, the water flowing near you is telling a story. It's part of this grand, geological epic, and it's just such a powerful reminder that our world isn't static. It's not a finished product. It's a living, breathing canvas, constantly being sculpted by the simple but absolutely relentless power of flowing water.